All right, we will go ahead and get started. Welcome, everyone, to a special virtual meetup we have this month, exploring effective data visualization with Dr. Cédric Scherer. Before we dive into a conversation with Cédric, I want to highlight a couple of housekeeping details. These sessions now, for those of you who are at Duke University, are available to receive RCR credit. If you want to receive RCR credit, then you need to do a couple of things. First, make sure that you're within the session for at least 60 minutes. Cédric and I today will be targeting a 60-minute discussion with various parts. So make sure that you are logged in for at least 60 of these minutes. Also, make sure that you signed up with your Duke email rather than your personal email via the special link that we sent out to the Duke participants. And then finally, in the chat, there will be a link for the virtual attendance sheet. So also make sure to assign this or sign this virtual attendance sheet just to make sure that you are here. So we can show this again later at the end. For those of you who are not here and not listening to it now, we will also then make sure that it is available. So it is my pleasure today to welcome Dr. Cédric Scherer. So I came to know Cédric through the Tidy Tuesday, our data visualization, ggplot community. That's quite a long title for a community, I guess, Cédric. And so today I thought that I would invite him to join us and have a conversation. First, we'll get to know Cédric a little bit. And then he will enlighten us with some of his ideas about some of the fundamental principles of effective data visualization. We all know there's more data around us than ever before. And we also know that the most important and meaningful insight that you make into your own data set is going to be virtually useless if you cannot take that insight and put it together in a meaningful and impactful way. And when I say put together, I mean to take those data and to visualize them in a way that anyone who wants to understand this message can understand. So Cédric will start by telling us some of these basic fundamentals. So regardless of the coding language that you use, whether you are working in Excel or Tableau that has beautiful visualizations built in, whether you are part of the R and ggplot community, or you're using any number of data visualization packages, these fundamentals will be important and useful and broadly applicable. Then in the second part of our conversation, Cédric will do some live coding for us. And so hopefully the nerves don't get to him. And he will then walk us through some data visualization examples. I believe that he has two examples, one of which we will dive into today, and one of which he has made publicly available, along with all of these slides that he will have, that allows you to walk through the example on your own. So if you like what you see here today, there will certainly be more for you to explore at a later time. And then the last part of our time here today will be to, Cédric has agreed to participate in this sort of Ask Me Anything style data visualization rapid fire. So I have a couple of examples of people who have submitted their own data visuals, and we will then ask Cédric what he thinks of these, but importantly, what his thought process is as he looks at this, sort of this thinking out loud, and give us some insight into his approach and his intuition into some of these issues. So with that, Cédric, welcome. I'm happy to have you here.
Hello all, nice to have you.
Okay, so let's get to know you a little bit, Cédric. So you recently completed your PhD. You're currently doing a fellowship, as I understand, but you've also then developed this a rare and esoteric, but highly skilled capability to take data and to turn it into these beautiful visuals. So why don't you tell us a little bit about how you got into this and how some of your sort of prior training has led you here today?
Yeah, that's correct. So I'm a trained scientist in ecology or in life sciences, then ecology and then computational ecology. And computational ecology already states it. So I was sitting in front of my computer nearly 100% of the time of my PhD. And of course, I also had to do some graphics for my publications. And yeah, then I realized this is fun after going into ggplot, knowing nothing about it. I learned it. I went through a full tutorial and I got really excited what you can do, because most people I knew until then use ggplot for simple rectangular graphics, simple scatter plots and stuff, but you can do so much more. And yeah, and I found this Tidy Tuesday challenge, which is one of several challenges I'm doing, but the one which I'm doing the most often. And yeah, it's great. It's a nice community, nice people, and other people trying to do everything with ggplot. And originally, yeah, I'm always interested in colors, fonts, design. I'm a perfectionist since I've been a child, so it somehow matches. So when I started studying life sciences, I was thinking about doing graphical design instead. Decided for the biology, and now, yeah, I can combine it again.
So tell us a little bit more. Some in the audience are going to be very familiar and perhaps have participated in Tidy Tuesday. But tell us a little bit about Tidy Tuesday. So what do you mean by this, and what is it exactly?
Yeah, Tidy Tuesday is a data challenge which is initialized by the R4DS community, the R4 data science community. This is a group of people, mentors, and pupils who go through the book by Hadley Wickham, who is the developer of the ggplot package, and try to help each other to go through the book and learn how to do data analysis and visualization. And I think the inspiration is coming from Makeover Monday, which is a similar data project, but not focused on a specific tool. They are mostly using Tableau, but they are open for everyone and any tool. And Tidy Tuesday is also open for anyone. But most people use ggplot because it's framed in the Tidyverse R environment. And every week they publish a data set or several data sets which are connected to each other, which are pre-cleaned. So rarely you have to do the data cleaning, but then you still need to manipulate it, to wrangle it, to aggregate it, to find your story. And some people also bring in other data sets.
So then give us a sense of the time scale of this. So you said as a child you were sort of interested in design, but then you ended up through school and eventually PhD in the life sciences. And so when did you really sort of take this dive into data visualization then?
Yeah, I mean, it's difficult to say. So my first data visualization with ggplot was in 2016. So with my first bigger presentation in doing my PhD, but I did some base R graphs. So, I mean, you're confronted with data visualizations as a scientist. So this was likely my first contact doing it actively, but not thinking so much about how to do it, but what I've seen from others. So likely default colors or colors I like, but not thinking about color blindness, not thinking about combining chart types or stuff like this. So more in a scientific way where you often have to follow certain rules. So you're often not allowed to play around with many annotations. So you have your box plot, you have your numbers on the axis, your rotated text labels and stuff like this. And yeah, with the Tidy Tuesday, it's interesting because it's a more personal thing. So I can do whatever I like. So if there are people saying like, okay, this chart type doesn't make sense to me, I learned something from it, but still it's a learning process. So I also trying new ideas and presenting it. And if people don't get it, then I will likely don't do it again. And I can play around with all types of colors and charts types. That's nice.
So I think the good thing for this audience is that you didn't say you've been doing this for 20 plus years. So you remember then sort of getting into this and some of the struggles that you had. So one of the last things I want to ask you before you dive into some of these principles is some people in the audience might be watching today thinking, I am interested in this. I would like to get involved. I have no idea where to start. I want to make my data more beautiful. I want to make it more impactful. What would you say to them?
Yeah, I mean, it's a hot topic currently during the last years. And so there are many freely available resources out there. There are many tools also for free, also paid ones, of course. So but you can tackle this from different perspectives, as we have said in the intro talk discussion, like from a more technical perspective, but also more from the science part. So I mean, I get inspired all the time. So look at other charts, learn from them, try to understand what they are doing. And I mean, this is a growing field, so it's always open to make new things. So yeah, I mean, for some things you need some experiences or some taste, and you will make some bad steps, and then you present it, or only check yourself 1 week later and you say, oh, what did I do there? So I read some books, but I wouldn't really say, I learned this systematically, learning by doing in this case. And I think some traditional rules, I mean, we are confronted with these data visualizations all the time in the newspaper, in the news, on TV, in the internet, everywhere, weather, money, all the stuff. It's all line charts and maps. And they are doing also not everything right. So don't get too much inspiration from all of them. But open eyes, and the more you go into it, there are several books which are pretty good. So also freely available. So if you want to do ggplot, there's the Hadley Wickham ggplot book and the R for Data Science book I've mentioned. Then there's a nice book by Kieran Healy. I can share the links afterwards, who also has a nice data visualization book, also doing R, but more on the science part. And then Alberto Cairo has nice things if you really want to dive into graphics and what people might have done wrong, and you want to find out what's going on there. Alberto Cairo is the one to go, but many more. I can share a list also if you like to.
Yeah, but that would be great for our audience.
I think open eyes, and if you're interested in design, I mean, design is something. There are rules, but also some talent and some learning how to place things, and also it's a thing of taste. So it's likely that the same visual is not liked by everyone. So that should help.
Perhaps a great place for them to start would be here today. So I'll turn over the presentation to you now, and you can take a little bit of time and walk us through some of the fundamentals as you see them of data visualization.
Thank you, Matthew, for the introduction and the interview. So I'm going to share my screen first. That's the best. Before it doesn't work. I hope you can see now this grayish picture, but we get more color in there soon. So we are talking about effective data visualization, and I want to give you some hints how I design my data visualization. I often get the question, where's the inspiration coming from, or are there any rules? And as I mentioned already, it's not always like, okay, rule A, rule B, it's design, it's about balanced design, but there are also things you can do plain wrong, at least in the eyes of the most people, and I want to cover some of those. So we already had a short introduction. So I'm a scientist and a data visualization designer. I'm going to skip this, and I'm using R for all of these, mainly ggplot for the data visualization, but also for the science, some other packages. And we will also have some R coding hands-on later, but the talk will not deal with any R code at all. So here are some examples first to get a sense if you don't know me. So as I said, I started with more scientific figures, and I'm still doing scientific figures for publications, which are likely on a white background and have to fulfill certain rules, such as legends, for example. We will talk about this later. But I'm also doing some client work for different purposes, for social media, and for blogs, and also for Matthew. So on the right corner, I'm not sure you can see my mouse. This is one visualization we have improved over the last weeks and months. And also, as we already mentioned, some contributions to challenges. And as you already can see there, I likely go a bit darker. I also have some white ones, but these are things you would likely not print in a scientific journal. So, this is not how it should look like. Can you see data visualization on top? No, right?
No, we can't.
I will try another browser just to make sure. Sorry for this. Yes, this looks better. Let's see. Okay.
You need to make sure your data visuals are appropriate.
Yeah. So now you can read the yellow font, right? Okay, yes. So what is data visualization? And it's a very broad thing, and that's why I also can't say you like, okay, this is the correct thing to do and this is not, because data visualization is any graphical representation of information and data, which means if you are standing on a wall and making a line of your height, this is already a data visualization, and if there are many people, you get some kind of a histogram or a dot plot. You can also frame it like this, like Klaus Wolke, who is the guest in the next seminar, I guess, in his book, which is also a great book. I forgot to mention The Fundamentals of Data Visualization, which is freely available as well. And it's part art and part science. And because it's part and part, it hasn't to be 50-50. So you have a gradient from very scientific visualizations to data art, which for most people are not really informative, but nice to look at.
Cedric,
yes,
we have one request in the Q&A.
Yes.
Just to make your new browser full screen. Can you do that?
Oh, yes, of course. Is this better?
Yes.
Great.
Looks great.
So usually you might think about data visualizations, such things like these. So bar charts, line charts, area charts. But there are also things like these, which is also a data visualization, but more on the data art side. So this is an example which I like to show every time, which is not a nice topic, but I think a very impressive thing by Sonia Kuipers. She did this and representing each person who committed suicide. So this was a personal project, suicide in the Netherlands in 2017. And even though these are not bars, you can directly see these are individual trees, individual clouds, individual buildings. So each of them represents individuals. So my point here is there might be ways of non-traditional data visualization which have more impact than just a bar chart. Also, this one you might know, this is the famous Napoleon map by Charles Minard. Which is considered as one of the best statistical graphics ever drawn. This is back from 1869, if I'm correctly. And the nice thing here is that we can see, it's a pretty modern way of talking about or showing data, because this is something reminds you, if you're into this as a flow chart or a Sankey diagram, which shows the troops of Napoleon and on the top of Hannibal moving to the right side and getting decimated. So the less people there are, the smaller is this flow. And as you can see, only a few made it back to France, and the black color is the way back. So, but the question now is what makes it a bad and a good data visualization? And we will start with the bad data visualization. So there are three things which can be wrong in the data viz, which is the aesthetics, so bad design choices, like maybe 3D graphs, for example. There might be substantive problems like bad data. You have wrong data, you have aggregated your data in the wrong way, so it's plain wrong what you're showing, or maybe also not the data to answer your question. And there are perceptual problems which are also related to how we can perceive. So again, the 3D bars, which might not line up with the panel grid or something like this. On the other hand, there might be, depending which book you are reading, 4 different categories, how you can create a good data visualization, and of course also how you can create a bad one. And I want to go through all of these step by step. So the first one is information. So which information are you using for this? Then the story, is it interesting? And should be interesting to spark interest. The goal, so are you using the right way to tell your story? And the visual form, so make sure it looks good and attracts people. But as I said, it's not as easy, so it's not a plain fight of bad versus good, and with the visualizations and the chart types, it's more gradient, and depending on who you ask, you might get different answers if you should make 3D bars or not. So the third thing is information, which means that you should understand your data and be accurate. I will not dive into this too much because it's the starting part of the data visualization and has not much to do with the visualization. But one book I can recommend is the Avoiding Data Pitfalls book by Ben Jones, which I found very nice to read. And I just want to share 2 main messages, which are very basic, but still I get them wrong all the time. So one of the statements I've picked from this book is our data is never a perfect reflection of the real world. And this is likely something we forget easily. And this has a wide range of different things. And for me, the most important is that we always have collected data, not in the terms of making errors, but it's also a part of making errors or collecting it in a non-homogeneous way. But more importantly, even though we try to collect the most perfect data, it will not be a complete reflection of the real world. So as an example, and I will also bring one of mine, but here by Andy Griebel, a well-known data visualization expert. I just Googled one and this came up and I found it pretty nice. And it's named Where Are New York Reds? And for me, I always try now to frame it like where are New York's Reds reported? So where have they been found or like this? Because we don't know if they are there or not. Also, you can now discuss if you should say have been or something like this, but I'm not about grammar here. But for me, this main thing is like we working with reported data. So I think it's always important also to state this in your visual, which is a minor thing, but by choosing text, which is very universal, we always try to make the big picture, the general picture, but be sure that this is not the case in most times. So just to show that I did the same thing, and this is a very recent visualization I did, or part of an interactive map. And as you can see here, it's about bike accidents and, it's about bike accidents. And I didn't write reported bike accidents. It's written everywhere here on top and in the legend, because I wanted to keep it short and we have this in the text. But still, if you just pick this, and most people know that bike accidents are reported, but still, yeah. It's not all bike accidents that happened in Berlin. No, that's not. Okay. And another thing I picked from the book is the best use of data is to teach us what isn't true. Because, the point of Ben Jones here is that we often have a story in mind already when collecting the data, or the latest when we open the text file or CSV file. And the idea is to challenge yourself to find something you want to find out with the data, not something you already know and you want to try to show it's true, but more the other way around. Okay, I come up with this idea, which is out of this world, and we try to find an argument against it. So he brought up the black swan analogy. So even though there are many, many white swans, and this refers back to the perfect data, there might be a black swan in there. So better search for the black swan than stating there are only white swans in the world. Okay, but that's enough for data. So there's much more which you learn in your R, Python class, or Excel. So story, which is also a very first step of doing your data visualization, but it's important. And there's also where your motivation comes from to do a visualization, because you have something in mind when you do it. And to be completely honest, with Tidy Tuesday, the weeks where I take long, these are topics where I don't have any interest in, or so be clear about what you want to say with your visualization. Also very basic, who is my audience, what I'm trying to achieve with this visualization. Again, there might be people who just want to have a nice visual seeing this and just have a warm feeling of this is art. And then there might be the businessman who say, I can't read the 2 digits from this number here. This is not a good visualization, but both are subjective opinions, and both people are in the world. As one example here, I brought the famous warming stripes by Ed Hawkins, and I think all of you know it. And this is from data visualization rules. It's total, a very bad visualization. You don't have any access. It's nothing written there. I mean, you can download a slightly annotated version, which at least states what we are looking at, but still, I mean, we don't know how many degrees this are, and you could now argue like, what's this? It's just colors. But Ed had a very, very prominent idea, I guess, of what he wanted to tell and how he wanted to tell it. And he wanted to focus only on the color. And it became so prominent and so famous that I think most of the people now know when they see this, that this relates to temperature. Of course, also some emotional reference with the blue to red gradient, which is normally associated with hot and cold. Another example very recently by Nathalie Bremer, a fantastic database designer. She did these posters, which are like the golden, I don't know in the English word, golden plates from the musicians. So posters you can hang on the wall, and these depict details of these songs. But it's not, the intention is not that you go there. You can go there and read it and have a look, but you also can just enjoy it without looking up every tiny dot and what this means. And as an example for myself, so here are two Tidy Tuesday contributions. On the left hand, this was an artistic thing I just wanted to try, and I thought it looks cool, which also got a lot of good feedback, but the intention was not to make it an accurate data visualization. On the right hand, a more scientific one, still colorful, but there's a long gradient. And if you go for publishing, you always go for the right-hand side, but doesn't mean necessarily that for every type of presentation you want to do with a visualization, you have to choose a bar plot, box plot, or scatter plot. Another nice example, also very recently, and these links are interactive, I hope. So I shared the slides with you, so you can check them out later. This is a great page, a storytelling page, where they show how maps in the media can make us more negative, how they can bias us, and not only maps, all visualizations, of course. So this is on the right hand, the red one, is a map by Frontex, which shows the illegal border crossings by migrants. And they argue then, or show you, similar to what I am doing today, how you could improve this or how you can change the story. We are here in the story. So on the left hand, the story is, wow, that's many people, we are overrun, panic. On the right hand, it's very informative, tries to be objective with these dots, the blue color, which is not panicking and stuff like this. You could also go somewhere else and also note the title, which is not illegal border crossings anymore, which also has a negative annotation, of course. So words also matter. But you could also go different and just show how few those are compared to other people coming and leaving the European Union. Or you could also show that recently there are not many coming, and the famous year in Europe of 2015 with the many migrants, the numbers are not as high as back then anymore.
Cédric, let me just chime in here. We have a question in the Q&A about the shared links. So I'll just clarify and let you correct if you need to add any additional information. But the shared links are going to be in the shared slides. You've made these slides publicly available. We have a link. It's live. We haven't shared that in the Q&A yet, but we will then take those slides. You all will have access to them. And if you click on any of those images, Cédric is saying that those images then will take you a link to the resource where he got these visuals.
Yeah, actually, it's not marked as a link, but the yellow. If you hover over it, you see that this is a link here in the caption.
Excellent. So we will share that with you all.
Yeah.
If I can, Cédric, you shared those with me, so I'll try to put those into the link for everybody to share.
I have also a link at the end of the code.
Okay, excellent.
Cool. Okay, so this was. I have to check out around. Oh, this direction. Okay, goal. That's the third thing we had on our list. The goal, which is in line with your story. So as you've seen, I already presented you some data bits because otherwise I would just have words on my slides. But the story is more like, okay, you divide it first from the data, and then you think about, okay, which chart I want to use. Do I want to use a map showing errors, red errors, or do I want to do a bar chart here? And there are several chart types and also several features which can be used to show information, to show values along a gradient. And there's some famous experiments, and this here shows you what is the most accurate and the most generic thing for people to read. So they tried how many people got it right, and as you can see, the 3D bars or the volumes are down here, and also packed circles are in the middle range, lower middle range, but you see them often. So this is more something, information to keep in mind, but you can often combine these details. And a world just with bar plots would be boring. So if you want to spark interest, then maybe also at least combine with something else. But I think it's an interesting fact to know. Especially for colors, which are often used, which are on the lowest end of this gradient. But just to show you that bars are not the only thing you can do. So in the end of last year, beginning of this year, before all these corona thingies happened, we had these severe Australian bushfires happening. And there were numbers about the area burned and the area covered with smoke, and I had no idea how big this is. And Neil Kane also did a map on Europe to show how large this is. So I think here personally the map works well better. At least for me as a European, I would now need to do this with the US, but I did also a global version for this. But yeah, bars, it's impressive how big this bar is, but there's no relation for me. So it might be easier to get something which I'm familiar with than just a plain number of square kilometers I can't imagine. Another thing is like we can also combine these. So as I said, you can color your bars, you can make shapes and colors, and you can also combine chart types. So that's what I really like in the most recent time of my visualizations, that I start combining different things I have learned. So these are two examples. So on the right hand, this was a quite popular thing on Twitter in the Tidy Tuesday community, which shows coffee ratings. And here I combined a typical dot plot, which gives you the histogram shape of the ratings for each coffee bean. But I added these interval stripes below to show where most of the data falls. And I also add a lot of annotations, these red triangles showing the lowest value to highlight this, and the black one showing the median. So yeah, you could only do a histogram here, but you could also combine them.
And then just a note, if you guys also see in the lower left-hand side of the plot, he also places his coffee cup there just for style points.
Yeah, I'm also drawing things, yeah, but very rarely. And yeah, I print it and then put it back up on Twitter. Yeah. And on the left hand, these are the moon charts. And I mean, I'm not going to rant about pie charts or to defend them. And moon charts might be as bad or as good choice. But I like them a lot. And here I combined them with a line chart to have another layer of information, which I'm not sure worked pretty well, but this was something I wanted to try anyway. So yeah, be also try to experiment and don't focus on only one thing. In general, if you're interested, like, okay, I cannot imagine much more than a scatter plot and a box plot and a bar plot. There are many helpers. Here I've listed some of them, where you can look up what chart types are there, and some of them are even like hierarchical clickables. On the left hand, the data to this, there you can even go like, okay, I have one variable, I have two variables, I have three variables, and so on and so forth. Yeah. Then the visual form. These are the design rules and the principles which I was actually aiming at, but then I realized that the other steps are too important to miss out here to just talk about colors and placement of text and stuff. And as you have seen in each chapter, I also related to the data visualization. So keep in mind the data is reported. So add this to your text boxes on your plots. The chart choice matters, not only if it's readable, but also what's the message to people, and the colors, very importantly. Okay, colors and common pitfalls. And I heard that Klaus Wilker is coming and talking about colors a lot. So I could also talk a lot about colors. So I try to keep it short here. Also very recently, a nice article by Lisa Charlotte Rost from Data Wrapper here in Berlin, a fantastic tool to build data visualizations in the browser. They have a wonderful blog post, which is called What to Consider When Choosing Colors for Data Visualization. It's really a phenomenal piece with a lot of these images, but a lot of text and useful information. And definitely check this out if you're into it. I just brought some of them, so you can explore the others on your own. Here, it's about color palettes. So on the left hand, we see a rather bad choice, and on the right hand, we see a good choice. This is about color palettes. So as I said, Klaus will likely cover this all, but there are color palettes which are used for qualitative data, so means categories. Ivan, David, Anna, and Lisa, these are persons, single individuals, so each of them gets a unique color. On the left hand, we see a gradient, and the gradient is for continuous data, so ranging from a low to a high value. So that's why it's a rather bad choice, but as you see, it's written not ideal. It's not like, okay, you can't read it. It's just like, if you look in the textbook, they will tell you use categorical colors, not continuous ones. This is something which I get often frustrated about, and which I always try to fix in my publications and visualizations in general. This is about being consistent with colors. So on the left hand, you see that China is one time blue and one time red. So this is the first thing which is not consistent here, but also that we have the same colors for two colors for 3 countries, which obviously doesn't work well. And here it's obvious, but if you have the line graph on one page and the other on the other hand, you might get confused, do not read the legend very well, and assume these are UK and China and not China and Germany. So better, of course, China is always blue, and Germany gets a third color here. This might be a bit less obvious, but this is about how we perceive a gradient of color. And on the left hand, we assigned the poor-rich variable to this, mapped the poor-rich variable to this color gradient, but it's very difficult to pinpoint the color on these gradients. So you could have a binned color range, like, okay, having only 4 colors and saying, okay, from $10,000 to $20,000. But you could also do it as on the right hand. You could just simply change the way of plotting this. So change the chart type and plot poor-rich on the x-axis and then use color to indicate the groups, which makes it much more easier to read for people. So there we combine several things. What I want to tell, what's the story, the goal. So maybe there's a better chart choice, and also the colors here, which might be confusing for some people. And one very important thing is misleading color palettes. And you might have heard of the rainbow color palette and the jet color palette, which are still considered harmful, and they also have real life consequences. So the other 2 journal papers are about misclassification in the medical sense. So what's the rainbow color palette? So this is this beauty here, and people like it because it's very colorful, and that's true. But the main issue here is that if we do this in grayscale, or if you have a color vision deficiency, you might not recognize each color. And it's even worse here. So if you have a look on the left hand on the grayscale version, you see that the 0.3 range has almost the same darkness as the 1.2. So it's not even only color blind safe, but you cannot even, from the pronouncement, the color itself doesn't pronounce certain areas. So you have dark colors for very, very high, but also rather low values here. Another nice example how this can distort your view, and this was, as I said, it's a real life thingy. So for medical purposes, this is really a difficult thing, because if you want to find urgently something in the brain, and the area which is of interest, it's marked in a dark red, and just before like 80% is a very bright yellow. It just you cannot do anything about it. It will guide your eyes towards this area, and this is what happened in these cases. So it took way more longer to find these areas. And here you can see in another example how bad and good color palettes play out. So on the left hand, the rainbow, and there you can see that some areas are just overpronounced, and on the right hand, you can still figure out what it's showing. I mentioned already color blindness. It's also an issue, and I'm definitely guilty. I'm rarely checking my visualizations in the end. I'm always planned to, and if I go for publications, I definitely do it. For Tidy Tuesday, it's often late in the night, and I don't want to mess around, and I pick my colors like 1 hour because I wanted to have the nicest colors, and then just to realize they are bad. But in an optimal way, you create your palette, then you check it, and then you create your data visualization, not vice versa. You're happy with this, and then you have to change it afterwards and be sad about it. But think about it beforehand. And there are good palettes. So if you're in R and Python, there are many palettes out there already coded for you. But you can just copy paste them also from the internet, and they are also helpers. So here I listed 3 tools. The last one is one. If you do ggplots, you can do it directly in R with a package by Klaus Wilker. This doesn't work. Okay, just move on. This was just a snapshot of one of the color tools. They are pretty nice, so check them out as well. And the last thing I want to cover is text typography. This nice combination of different fonts is by Will Chase. I just stole it from him. But these other slides are mine. So fonts. And I often get the question, and it's not easy. So if you really want to have a overall balanced design, fonts is a big thing, and there are many books, blog posts, and stuff you can read about it. Again, you will realize that there's also not the one true answer about that, like sans serif or serif. People argue, and you will always end up with a 50-50 split of people liking it or not liking it. But in general, there are some rules you can follow at least to make it work better. So the font should fit the topic, which means if you have a modern topic about the internet, you should not use very old styled letters and vice versa. You shouldn't use very squiggled and fancy fonts. So there are display fonts, which are display fonts for that purpose. But if you have a large chunk of text, it just makes it difficult to read. Also, some fancy or especially squiggled fonts look very childish. So some people like them, but at least be aware that maybe 50 to 80% think like, okay, that's a child data wish. The other thing is not that obvious. So visualize hierarchy. There are many ways to do it, but there's something, the feeling to balance that. You can over pronounce some areas and others, but I will also try to cover that and avoid using all caps because it's a screaming intention. But as you have seen, I have also all caps, and I'm actually a fan of all caps. Depends how you do it. But definitely don't combine it with exclamation marks, and not many exclamation marks if you have to. And a thing I have, it's close to my heart, is use a monospace font with lining for numbers. So if you have many numbers, or if you're working with tables, you should make sure that your numbers are nicely aligned. I have examples for all of these on the later slides. And consistency is key. So don't use 6, 7, 8 fonts and each label gets another font or typeface. Choose 1, 2, 3, maybe if you need 4 fonts, but then be consistent and use them for the same purpose. Like highlighting is this font, block text is this font. Okay, hierarchy. So there are different ways how you can build hierarchy, and you can go with size. And just go rush through these slides because I think it's rather obvious, but just to have them all together. You can go by the font face, so underline it, make it bold and italic and stuff like this. You can go by color, of course, but you also can see here already some problems. So the light gray might be too light, and with the size, the smallest one might be too small. So there's always a trade-off between these things, of course. You can go by spacing, simply, like you see it in every normal web page with the typeface, so different fonts for different parts. And of course, you can combine these then, and this is what you likely see in your newspaper. And also if you have a subtitle, of course. So in the end, you can use all of these. I don't think there's too much. It's about, if you have a colorful database or not, and so on and so on, if you should use too many colors here. I said not too many fonts because this might get frustrating. And here again, it depends how much text you have on your data visualization. Their data visualization, they come with just 2 axis labels. That's something different here. Of course, you shouldn't then use also 4 fonts for these 2 axis labels, but I'm now talking about infographic styles where you have a lot of text, arrows, and explanations. And there are you likely ending up with several fonts if you're a fan of this. And that's a shame that this is not working. It did. I will make sure that you will get this afterwards. So 1IL test, I call it, or I found it. I'm not sure if this is the official name, but if you pick a font, and there are some people who are really very rigid about this, is that you type a 1, a big I, and a small L letter, that they shouldn't look all the same, which is very often the case, especially for sans serif fonts. So this is something you could check if you are into these things, because there are really people who get annoyed by this. And again, depends. If you have no numbers at all, it might be that important. But if you have longer texts, then it might get frustrating. The monospace numbers, here's a nice example from a blog post on Medium. Didn't link that one. We'll do this later. So you can see that Montserrat on the top, they have proportional numbers. So they have different sizes, widths. Then below you have two tabular or monospace numbers, which where each number has the same spacing, which means in the table, also on an axis description, they beautifully line up. And yeah, I think this is important if you have these logarithmic or very long numbers or tables, especially, that you make sure to use these. Okay. Then this is yeah, also quite obvious, but it's a lot about symmetry, and you should align your text as you do with your geometric forms in the graph as well. So this is again an example from Will, he picked from 538, and they got it all right in this graphic, but they made one mistake. Not sure if I should tell you or if you want to find it yourself. So I will keep on talking and you can find it yourself. So we left align most of the text as we usually read it, at least in the Western world, in our books. Also the title is often left aligned, but there we already start exceptions from the rule, because for infographics it's often centered and stuff, and I also very often center my title. And yeah, but at least make sure they somehow line up and you have some consistency here and no sudden gaps. And the sudden gap here, if you didn't find it yet, is in 2014, which is a bit off from the middle axis here. I didn't spot it, William spotted it, but yeah, I would do so. Okay, and then the last thing is don't rotate your text. I think this is an easy tip one can do and do by heart and learn by heart. And this is something which is just a technical thing. So what people tend to do if titles get too long, they put an angle in there, and depending on the angle and yeah, the tool you use, it might even look a bit crappy, but it definitely will make you do like this. And also on the y-axis label, we already get used to it, but this is, yeah, from a database perspective, for making it people easy to digest your data visualization, this is not a good choice. But this is then, now we are going into this area of what the art people say and what the science people say here. Or, I mean, for me, coming from scientific publications, I'm not sure if I would publish a figure where I don't have an y-axis label. But what you can do usually with data visualizations, you can put often everything in the title. So we don't need movie anyway, because for most people it's crystal clear that Star Wars and Jumanji are movies. But you can even put this on the title, like weekend gross in million USD. And we don't rotate the labels. And if you get very long labels, or maybe it's even a nicer choice, you can flip your chart to make it even more easy to read it. And we can even add annotations, so we can get rid of the grid lines if you like. You can, of course, also have both the grid lines and the annotations. So here we label the weekend gross in $1 million directly to the bars. And if you have a story in mind, then of course also highlight what you want to tell to guide the reader that we here want to focus on Star Wars, which is anyway the biggest bar here. But if you want to focus on Pitch Perfect, for example, it might be more important to highlight this, that people don't need to search for Pitch Perfect first out of 20 movies or so on. And I think that's it. These are just 2 pages of mine, so we will head over to the GitHub for the coding exchange, but they are all my Tidy Tuesday codes and some others. I share them with the community. So if you see a plot, or if you have seen a plot in the talk and you want to know how to do this, most of the code is not commented, but you can reach out if you struggle. And I have a blog, where I also from time to time share something. Unfortunately, not that often in the last weeks. But 2 blog posts I want to highlight here, which found quite some traction by people. I published a ggplot tutorial, which is quite extensive, and I'm currently working on an update, which was initially published by Zeph Ross, but over the last 4 years, it really emerged in a small book now. And on the right hand, there's the evolution of a ggplot, which was the start of my Twitter fame somehow, which people still like to refer to, because I cover as well how to build a ggplot step by step, but also some smaller perfectionist choices, why to put which layer on which layer, and to avoid overplotting and stuff like this, and how to combine different things. Yeah. And these are the hands-on coding examples. I'm not sure, Matthew, do you want to say something? Or
Yeah, so a couple of things. First, thank you. That's a comprehensive introduction, but it's also a really generous offer to share your code, share the examples, encourage people to reach out to you. So that's kind of you. I would also add that one of my first introductions to Cédric was his evolution of a ggplot. And I share that in some of my classes. And I think that not only showing the code and how to take a ggplot and make it beautiful, but the fact that it's written in a blog format means that Cédric can sort of comment along the way and, as he said, sort of describe his decisions and where he takes some license to do something one way and decides not to do it another, and so on. The only thing that it doesn't have is all the mistakes that he made along the way and the decisions he abandoned. But certainly the logic of stepping through that I found quite useful. So I think that in this next part, Cédric, why don't you take your shorter of the two examples? The link to the examples, if you'd like to follow along, or if you'd like a link to these slides, that's shared in the main chat. So you can find that there. Cédric, then why don't you go along and do some of your hands-on coding? And we'll wrap up with this sort of quick sort of AMA style, and then send you all on your way. So sort of the transition now is going to be towards this a little bit more technical, showing how to use some of the tools to do these things. Cédric.
Yes, let's do this.
All right.
I'm actually not sure which is way shorter now that I think about it. One is a bit more code, but only 3 charts. The other one, yeah, let's do this. I'm going for, so first I need to share it. I don't see anymore.
I mean, the other thing that we could do here is we'll just, we could ask the audience to decide.
Yeah, we could.
Depending on who is still here.
But now you can't see it anymore, right?
No, we can't. If you go back, so let's go, let's see, Tiffany, is the chat open for anyone? Or is it just open, is the Q&A open for everyone?
The Q&A is open for everyone, but not the chat.
Okay, so we're going to totally sort of break the Q&A. But we have 2 different examples here. We have one that is a time series, JP Morgan Chase Institute, and one is a gene distribution, actually of a project that I'm working on that we've talked about in the past. So why don't you go ahead and light up the Q&A and just put your vote, whether you want to see this time series or you want to see this sort of histogram style, this smoothened histogram. Which of these is more messy and which of these do you want to see? And then what we can do is we can sort of quickly see which of these 2 is going to overpopulate. Right now we're about 50-50, okay, maybe 60-40 time series. 70-30 time series, gene distribution, okay. Back, we go to time series history.
And, let's do a bar chart race.
Exactly.
Oh, I didn't cover this.
Okay, I think that the time series has edged out the gene distribution, which actually, on one hand, disappoints me. Because, of course, the gene distribution is sort of near and dear to my heart. But on the other hand, it sort of preserves the integrity of my relationship with the audience, because I made that terrible-looking smooth gene distribution plot on the right, and it will save me from Cédric of having to correct my poor graftsmanship. So anyhow, okay, let's do the time series. We have some late votes now for the gene distribution. We'll save the gene distribution for another time. In fact, what we can certainly do is Cédric has the code already there, but we might be able to implore Cédric to do a quick self webinar sort of screencast of him walking through this, and perhaps we can then share that with the gene distribution aficionados later on. But it's sort of in the interest of time, we'll choose one. Let's move forward with the time series, and then we'll be able to send emails out where we can point you to future content. We can point you to the recording of this. If you want to watch it again, we can point you to these additional resources. So I think that would be a good plan to keep this moving forward.
Great. So I'm not sure if the link was already shared, so you might also want to follow the code, but since we are short, let's see how much I explain anyway. So I quickly set it up here. And I did these plots already, but I'm really trying to do this from scratch now. So let's see how this works. So we are going to open a new file.
While he's doing that, I'll just chime in. Somebody, anonymous attendee, asked recording, please. And there's two things that I'll just mention. The first is this is being recorded. So if you're watching it now, you have to leave early. We're actually almost at an hour already. So if you have to leave after an hour, you can watch the latter part of this. The Zoom link will be shared. We'll post this on YouTube to make it broadly applicable and evergreen. Then also, I'll see if I can twist Cédric's arm to be able to have this auxiliary recording of this second session. But we'll share all of these other details with you. If you've registered, if you're here, then you certainly, we've got your email. We can just let you know about these additional resources.
Okay. So the timeline one, right? Okay, so this is for everyone who is completely new to it, this is our studio. So this is a script where you can type whatever you like. So we can write some text here and we can write some code here, and what's inside the code will be executed. And that's where I'm typing. So we first are going to load the tidyverse package collection, and the code is evaluated down here just that you can see it. And yeah, since it's a notebook, so it just tells you that there are many packages in here. The most important one for us is ggplot, but I will also use some others. That's why I'm loading all this. And if you don't have it installed, you can go first for this one. But since I have it already, I don't need to run it anymore. The library you need to call every time. Okay, then we need the data. I just simply call df here for fast typing, and I'm going to use the data with the readr package, which is for making and made for reading data. And I'm here going to read a RDS file, which is an R-specific file, and I'm just now going and hopefully reminding correctly where the file is laying. So we pick the JPM example. I hope this works now. Looks good. Okay, so now we just have read in the data, which is here. You have seen the line plot, but we will just quickly code it. First, let's see what's in there. So what's this data? We have 4 variables only. We have a date, we have a change, a category, and the ID. The ID is also the date. I scraped this data from the visual directly by clicking on the points, and since there was some digits wrong, I just added quickly an ID. So what we are going to do is for each category, we show the change in spendings over the dates. Yeah, that was the original plot. So let's try to recreate this. Let's see if I can even maybe include the picture here. If we see the original one. Sure. This works now. Oh. No, okay. I will quickly do the original. So we always start with a ggplot call. And the first argument of our ggplot call to build a plot is the data. The data we called df here, data frame. And the next thing is, which often causes frustration for beginners, is the aesthetics parts. So we call this the mapping. So we map something, some aesthetics to our values, or the values to the aesthetics, to be more precise, which is in the first place x and y. So also X and Y are aesthetics, which are positional aesthetics. And we map to this the ID, so the date on the x-axis and the change on the y-axis. And we want to have a line plot, so we add a geom, which is a layer of ggplot, to add some geometric forms to the data and the plot. So if we run only the first line, we will simply see a grayish default ggplot thing where we already have the ID and the change on the axis titles, and we see already the range covering, but we don't see any data. And this we add with the geom line call, and now you can see this strange thing, which I knew will happen, but I want to do this to make you aware of this. So, sorry. what we are going to do is we need a grouping variable, which is the category. And now I deleted something. So there we go. A bit bigger is anyway better. And if you want to have colors as the original has, then we can also add colors here. So that looks a bit like the original graph. We can now quickly, just to show you how we usually do this, we can change the theme, for example, to make the gray go away. We can also use some nice other colors, which is, for example, the art to color package, and I'm clicking wrong thingies and stuff like this.
Cedric, just one thing to interject. Yeah. So I changed my camera feed to be the original plot. So as you sort of build it, you can just use that as a reference.
Yeah.
And then second, some of you have commented that the workshop files for the gene example weren't working. I also tried that. The link is broken. That's fine. After the live stream is done here, we can go ahead and update that. So just hang tight on that. But Cedric, you can go ahead and come back to this.
Good that we picked the other one. So this has to be color here. Sorry for that. I will definitely change that. Okay, so that's close to the original. We have some line here and some annotations, but yeah, just to give you a feeling how you do this simple plot. And what we can do now to change that is we could use a facet, which is a very powerful thing in ggplot, which means we make small multiples out of this. So we can simply copy the whole chunk. And this is a single function, which is called facet wrap. And then we just put the category in here, so the variable which we want to facet it by. And if we run this, hopefully, yeah, we get small multiples. So this might be already, depends here a bit on the story and the goal. And I don't know the original story of this plot. I think it's about, here was the Corona national emergency in the US, and then how did the different categories evolve over the time afterwards. And I think it's about winners and losers. So I assume losers, which is mainly transit, fuel, and other healthcare. So one thing is missing. I'm quickly adding it here just to also show you that you can quickly add these things. It's the V line with the emergency happened, which is around 11. We can make it gray. We can make it dash as in the original. And we get an error because I put a dot here and we forgot the plus sign. So you can see there goes a lot wrong, and this is not just me panicking from the live stream, but that's a usual thing when you code. So this is one first thing we can do. We can also, to make it easier to compare these, we can also add a baseline for the 0. So that's the horizontal line, the H line is the y-intercept, and this is 0. And we can remove the dashed, which makes it already easier to compare these, not each line with each, but you can easily see the whole pattern of a line. You could also do something else, which is highlighting the losers. As I said, it might be about those categories which do not perform very well afterwards. So what we can do is we copy the code again, and we can use a package called GG highlight. You can also do it by hand, but the GG highlight is very nice, which allows you to highlight certain groups, so categories in our case. And how this works is, let's see if I can remember it. We have a GG highlight function, highlight, and then I guess I have to look it up. So we can either press F1 to get the help, or I have a quick look at my code. So I'm rarely using this, but it's a very neat package. So here we go. We add this. so a bit more complicated. So here I want to highlight the lines which have a change that is lower than 50% decrease. So these last three likely on the last day, which is number 15. So on the date 15, give me those which are below minus 50%. And yeah, we can just see what this does. So if we run this with the plus sign again.
Cedric, we also have a question about how the figures are appearing in line with the code.
We can do this. Yes.
I assume that means rather than over in the viewer.
This is, so we could also do this in the viewer. This is, I rarely do this, but I like it for teaching reasons. So for myself, I don't like it this much, but this is, if you go to a new file, this is it's not an R script, this is an R Markdown or an R notebook. I never got the difference between those two, actually, which by default print every output, also the tables in your notebook, like the, if you know them, the Jupyter notebooks for Python. So that's why we can write some text in between and then some code. If we would do this in a simple R script, then we would get the result. Let's see. This is a simple R script. So then we would get the result in the viewer by default. Oh, no. Or in the console. Yeah. No, I broke something, unfortunately. So it's not a good idea. So I rerun everything. So this is these markdown documents, and you can change if this is shown in the notebook or in the viewer here on the right hand. Here in the settings, there's the chunk output inline or chunk output in console. This is the option you have to choose.
Yeah, Seth, I think Seth was asked the question. I think it's default behavior to appear inline. That's one of this R Markdown type document.
And now I have the first error here, so I definitely have to check now what's going on. But that's the joy of live coding.
And while you're doing that, Cedric, also Nicholas has to just gives an FYI. Jupyter just isn't for Python, works with R, Julia, and Python as well. It's interesting. Yes. There's several, including RStudio. There's several the integrated developer environments, these IDEs, that are moving towards this polyglot, this multi-language sort of platform to enable people who do speak multiple languages, not just German and English, but who speak multiple programming languages to have an environment that they can perform all of their work in. So thank you, Nicholas, for bringing that up.
Yes. So in the meantime, definitely. Jupyter is great as well. I'm an R user and I love the R notebooks, but I rarely do these inline chunk outputs. But I know many people who like it. So I quickly just added the points also to show you, to be more close to the original, but also to show you that you can combine several layers. So you can have a line and a point, and you could even now add bars and whatever you like. Okay, but this was the plot I was trying to run, and now magically it runs. So if we have, you can see here it's not perfect color because this is very grayish compared to those. You could fix this by removing using the default colors, for example. Now you can see it highlighted by automatically these lines, and if I'm changing this variable here, I can even highlight more, and it becomes difficult to read. But so it even has this inbuilt direct labeling of your highlighted groups. And here there was also this option to use direct labels, and which is false, and then it draws you a legend, but only for those which are colored now, because the other one you couldn't refer to anyway. And so these have both their pros and cons. So the pro here would be that we don't have this spaghetti plot, everything is clumped together, and I cannot follow especially those trends which are not that extreme. Here it's easy to follow these, but I cannot say which category is this. You could solve this by interactive plots, of course, where you highlight the lines. So this is another topic. We are now talking about static visualizations here. But there are also ways to make your ggplot interactive. For example, ggplotly or highchartr. But we are here focusing on static ones. And I think the plot by JP Morgan chase was also a static one. So what we can do now, and this one I definitely have to look up because it's a bit more complicated. We can combine the facets and the highlight thingies, and we can just try what happens when we do it. But I think there was a reason why I wrote this big chunk of code back then. So this is a visualization I improved quite some time ago for a client of mine. Okay, yeah, and that's the reason, because it only picks those 3 highlighted ones now, and not all anymore. But we want to show all of them. So we have to trick a bit. So what we are going to do first is, let me quickly have a look. Yeah, we save this as a plot, as the first plot we wrote. And then we combine it. Let's see. Okay. And I think what it's doing, let's see. Because now we are again clicking the light, and I think if I remember correctly, this was not very intuitive at the first moment, and it doesn't work. Which was okay. Let me see. Okay, I will, for quickly reason, because we're already over time, I will quickly cover the whole chunk here. This was not
all right, so while you're doing that, I can just interject just to make sure that the viewers are understanding the challenge here. So the challenge is that you have a GG highlight, and you highlighted a couple of lines that are of interest in the original mess of lines. Again, if you look to the right of your screen, you can see in place of my face, we have the original plot, and you can see it's a mess. And so we want to highlight a couple of them. And so Cédric has done that. But the challenge now is if you facet, he faceted all of the categories at the beginning. But now when he's faceting, because of the way GG highlight works, he's faceting just the couple that are meeting a certain criteria. Is that correct, Cédric?
Yes, that's correct. And as I've shown, if I just add the facet here, then we end up with 3 facets, but we want to have all of them. I'll show it again. And this was something I'm not sure if I found the solution by trying or if I Googled, but this is not what we want to have. So in the meantime, I copied the code. So I'm not sure why it didn't work, because I think I had almost the same. Yeah, we don't need this. Okay, now I saved this plot in something which is called GG, but I can also run GG, and then we can have a look how it looks like. So now we see that we have, we already have the combination. Because I don't want to highlight these 3 anymore, this I would do with colors now, but I want to have the line highlighted, which is in the facet, and show all the others in the background to have a reference. So I still can see that these are very, not only close to the baseline, but that they are way higher than some of the lowest one, or that some peaked here while others didn't, which might be difficult across these small multiples. Yeah. I hope this makes sense here. So this is again combining several ideas, and it's a bit like how I moved to this. So when I saw the original plot, I was like, okay, I don't even know what's the story here. So I first had to figure out what this is. And then it was clear to me that somehow I want to compare the lines, but still want to follow each pattern. And both solutions I had in mind first, of course, did not solve it. This one makes it easy to follow each line, but hard to compare. And the highlighted one makes it hard to follow single lines, and especially not the extreme ones. And I think I will stop here the full code. I did some more. If you look in the tutorial, we added some the line and the text box and nice labels and stuff. I can go quickly through this if you like to see the code, but I think we are over time quite some. So I don't know what's better.
Yeah, I think what we would do instead is just have a chance to answer a couple of questions and then move on to this.
I think this is better.
So, Alexander asked a question: how do you change the encoding for your marks? Maybe remove the points.
For the marks, switch marks related to this plot here?
I think so. Alexander, if you're still here, maybe you could clarify a little bit more. How do you change the encoding for? So within ggplot, this is where you change a geome. So if you change the geome, you change whether or not it's going to have points or lines or the different elements. So if that, yes, remove the circles for the points. So I think, Cédric, that he's then asking about the geome. So if you use like a geome line versus another geome to put the points on or not?
Yeah, I quickly do this here. You can simply exchange them. I mean, not all geoms work for all, because some geoms need one variable, some need two, some need three, but all which need two, so an X and a Y here, you can exchange, so or not. Oh, a typo. Yeah, so you could do a line, but you can also have some points here. And you can look them up. There are many in default, or by default. But there are also several extension packages which allow you to do stuff else. This didn't work out well. But yeah, you can see in my script that I have in the end, I also shaded the area to make it easier to refer to the baseline. This is another thing. Yeah.
And then why don't you just add a geome line and a geome point as two layers there? And then I think that then is going to answer Alexander's question.
The idea here was because you might remember your high school teacher talking about you in math that you are not allowed to connect the dots. At least I remember this because each dot is a single measurement, and the line would somehow indicate that you can interpolate between those 2 points, but you can't. And in this case, you have seen the dot plot only, and it's total mess. So it's a good idea to still show the raw data. So where did the measurements happen? So there's no measurement in the middle of this line here. Could be here, could be there, could be on the middle. So that's always good to combine a line and a point here. Yeah.
Okay. So then in the last couple of minutes, let me go like this. In the last couple of minutes, what we'll do is we'll maybe just have time for two of these rapid fire questions. So the hope here, and again, just a few more minutes, is to both have some fun with Cédric and put him on the spot, but then also we want to sort of see his thinking live so that we can understand when he sees something, like where does his mind go and what does he see and what does he not see and so on. So I've got two examples here. This, I just want to highlight, this is the website where the information is. This is what it should look like. But we'll just do two quick examples. So, all right. Actually, Philip asks one question before we get going. What is your go-to tool to combine charts in R?
Yeah, big topic, but yeah, definitely patchwork. I mean, there are things where when it doesn't work, but patchwork is the latest and I think the most easiest to use.
Yeah, so patchwork is a package that's designed to work with ggplots by Thomas Peterson, I think, that then makes literally the code and the language to do this is you take your G1 object and literally you say plus G2 and there you go, you have two plots right next to each other.
Yeah, so if it's about placing plots next to each other, if it's about inset plots, then you would go for cow plot, or you can even do this by pure grid, which is the underlying package from ggplot, but I rarely touch this. Okay.
All right. So the first is by a Twitter user who asked about this week 39 exploring Himalayan mountain ranges. So first, Cédric, did you participate in this Tidy Tuesday challenge?
No, not yet.
Okay.
No, I had too much on my plate.
Okay. So then we'll just go ahead and dive into this one. So did you look at the data or did you have any sense of what the data set was that then the challenge was to visualize?
Roughly, but we can go to do this shortly together so that people maybe also see the Tidy Tuesday page once during this session here. So
so I'll stop my screen share. You can put yours up again quickly.
I will quickly just show you where might be a good idea where the Tidy Tuesday thing is happening. It's also on GitHub mainly. I mean, sharing on Twitter, but the data is here on GitHub. And there's some intro, and then here are all the data sets. And we are, this week Beyonce and Taylor Swift, but we are still in the Himalayan climbers. And then if you go there, here is a dictionary of each of the data sets. So this is how it looks like, just to give you a sense.
Okay, so we have a data dictionary. It's basically very early on in the Tidy Tuesday challenges was to try to recapitulate a plot. Then they would give you the data and they would give you the goal to try to emulate. But then I think quickly they moved on to here are data and open up to the community to say, show us your best visualization. So one is by a Twitter user here who asked for your perspective on this visualization. So this looks like it's the distribution of heights in meters of all the Himalayan mountain peaks, which have been scaled at least once. The bubbles represent the top 5 nationalities of the mountaineers from the first ascents. So it looks like we've got each of the Himalayan mountain peaks is a line. What would you call this plot?
Yeah, I mean, first, it's more in the data art than in the data viz part, if you want to classify it on this gradient. Yeah, I mean, it's a circular bar chart with a dot plot in the middle, I would say. So yeah, this could be now a good or a bad thing. Like, okay, it motivates you to think about it. I really need to focus first, have to read the text to understand it, of course. So it's not something which you can easily digest. So that's my first observation here. What I've seen this on Twitter already, and I think it's inspired by Georgios plot from a few weeks earlier, where he tried to make volumes. And as we have seen, the volumes are pretty low on the easy to read rank, and this is where the overlap is coming from. So I'm not a big fan actually from these overlapping circles in the middle. This is just my subjective opinion on this.
Because it doesn't add any information?
It doesn't add any information. In this case, it might work for the example I'm talking about. This was kind of like really excluding area, and I'm not sure here. It's easy for my mind to fulfill the UK circle, but still I don't see the point of overlapping. So if it's an artistic choice because there's a nice effect, then totally. But purely from digesting that, I wonder why are they overlapping? Is there a reason for that, or is this on? Yeah.
Okay.
Just by chance. I mean, the circular things are difficult anyway. So it's always, and you're often ending up with more data art and data visualization. Like people who might into business decisions and really like textbook data visualizations often don't like it. On the other hand, very many famous designers do very often circular designs on the data art end. So yeah, I mean, what's good here is that I can easily see that there are many, what was it? The high peaks have been scaled at least once. There are many mountains between 6K and 7K height, right? So this is a mount thing. Of course, there are different ways to do so. But yeah, I actually like it, but it's definitely not easy to digest here. Okay. I would maybe add some annotations to make it easier to grasp what's really shown, what each line means and stuff like this, because then I need to go in the subtitle first to figure out.
Yeah, I agree. When I look at it, I see the question that immediately comes to mind is whether each of these points represents a single mountain or a single mountain that was scaled. Yeah. And so I don't know if each one is a person who scaled a mountain or each one is a mountain range or a single mountain. So
yes.
But I agree with several of your points there. Okay, we have time for one more then. Let's then come to this one. So this is a classic. I won't play it, but this is this classic bar chart race of distribution of charts over time. So in fact, I won't play it just again to try to save time. So here we have COVID-19 cases by U.S. state, and then we start out with a date there, and the date then when we hit play marches through time, and we can see this. Sometimes they call them racing sort of charts, or what do you see here?
Yeah, so I mean, it's a very clean design. So what I really like is the direct annotation. So the number of these cases behind each bar, which helps a prominent label for the date. But this is common for these bar chart races. John Ben Murdoch, I think, invented those. And then we had a peak hype 1 month. Everyone was doing these. I did also one. But what's one of the first things which which kind of makes me wonder or frustrates me is the many colors here. I don't see an added value. So if it's sorted by some west, east, north, south thingy, or by time, then it would maybe make sense. But if it's just like, okay, this is a color for a unique state, because every bar is a unique state, there's no color doubled. So I don't need the color code here. And I think it's, for example, driving my eyes to the Arizona bar for some reason, because it's yellow between those blue ones. Yeah.
Oh, now we're testing your knowledge of US geography.
Yeah, definitely, and I'm not going to comment on that. But actually, I don't see a pattern, because at least CA and FL are not close to each other, and both are green. So so if I would color them, I would make this for a reason, like as I said, geographical, or you could even say, okay, we color it from date when it first started, so that we maybe see, okay, now all these where it first started are grouping together, but at some point the others go over it, because this is the fun thing, like follow your state, follow the heads up state. I mean, in this case, it's a bad thing to follow, but it's of course a very, very engaging, motivational graphic. That's why they became so famous in no time, because people love to sit there and it focuses you. It makes you stop because it's animated on Twitter and stuff. And then I would go for something like this, I guess, if I would color code them, or group them by something if you want to have color in there. Otherwise, pick one color and fine.
So in the Q&A, we also have a person bring up the question about normalizing by population. So we also might then conclude from this is that California and Texas are among the most populous states. And so what do you think about when you're making decisions of trying to show something by a geographic area, which then is oftentimes larger areas, more people, et cetera? How do you go about those decisions?
Yeah, I mean, it's not easy. And I think especially in the Corona context, there's been a lot of discussion. So John Ben Murdoch, I already mentioned for the bar chart races, but he's actually also a very famous data-viz designer in the context of Corona. In the Financial Times had some famous graphs there. And he wrote a lot about log scale, non-log scale, and normalizing or non-normalizing. And happily, I'm also have my background in disease ecology. So I found it very interesting to follow all these patterns. And it's also about the time point when we look at the pandemic. So in the beginning, the number of people in a state or in a country, in a county or wherever doesn't make sense or doesn't make much difference. The most important thing for the virus to spread is its density, so that I have someone close whom I can infect, but not that there are many, many people in a large area or vice versa. So in the beginning, there was a lot of arguing for normalizing, but actually I found this not okay, or if you would do this on a very small scale. I also get that, especially the Americans are saying like, yeah, we are a big country, of course we have the most cases, which also makes sense. So time is an important thing here. In general, I like to normalize, but also this is a human component. And if you now look back at one of the first data visualizations I've shown you by Sonja Kuipers, the suicide data art, we're talking about people here. And of course, it's 200,000 people. It's something else triggering than like 90% weight or something like this. So I think the big numbers are also important here from an emotional perspective. I might quickly show what I have done for the Corona. So I didn't do anything for quite some time. At some point, I had the feeling I thought enough about it. So this was my plot, but this is normalized actually. So this is not by states, not by American states, but worldwide countries. And what I did is I scaled the cases per day. This is not smooth, but I also did some smooth ones. The cases per day relative to the highest number. So it's proportional to the worst day. That's why I called it the worst days, which easily lets you see patterns within. I mean, I sorted them even by the most, in most cases. But yeah, that makes it, for some people, it's more easy to compare between countries, but on the other hand, there are several other factors influencing this. So in the Corona context, it's a very difficult topic. And I think if you're unsure about these things and your data visualization has some impact, I mean, everything we put out there could have potentially some impact because it's somewhere laying there, and in 5 years, someone finds my Corona or non-Corona visualization and shares it with in some dubious groups or something. So we always should try to get something out there which is meaningful, but of course this happens. But yeah, reach out to an expert if you don't know much about the system. So within this blog post where I wrote a blog post about this, I also argue a bit, what I've done, why I've done this, and I also have a part of, do I need to adjust for population, with some important links here. So if you're interested here, I collected some ideas. Also about the colors, because many Corona visualizations were bloody red in the beginning. Also the famous dashboard by Johns Hopkins University, it's red on black. It's like, okay, there's blood all over, these dark times on Earth, which might be by intention or not, but yeah, it triggers panic. And from my perspective, yeah, it's an important topic, but nothing to panic about in such an extreme thing.
So we can certainly share that link to this blog post and some of the follow-up notes. So then we have a couple of rapid fire, just final questions
yes.
that we might then just allow the audience to get through and ask. If you have any final questions, go ahead and post them there before we wrap up. So Khalid asks, besides Tidyverse package, what else do you personally use to produce some of these great visualizations? Or maybe said another way, do you extend beyond some of the packages that these independent developers are working so hard to produce and maintain, or do you primarily stay within the R and developer ecosystem?
I stay within R, but I mean there are also several commercial anyway, but very small contribution packages. One example, which is really just one person doing many packages by Thomas Peterson. So Patchwork is a great package. He has the ggForce package, which is great, which comes with many gems, which are fantastic, very specific, but very interesting. In the other example, with a gene distribution, I use the ggdist package, which comes with several distribution thingies. I love them. Every third plot or so, I use this package. And ggtext for sure. I also have an example in the other, unfortunately also in the distribution example, it's ggtext where you can color text, which is great.
Okay, excellent. So then I think what we'll do is we'll just finish on this the discussion around coronavirus, I think highlights one of the important points that you made at the very beginning, which is when you're setting out to make a visualization, you made the point when thinking and consulting and thinking some more about coronavirus, then you decided to jump in and join the fray and make a visual. The important thing that links back to what you said early on was that you need to first decide what's the message and what are the elements that you will then choose to use to carry out that message. If your message is one of panic and fear and importance, then you might make a decision to use red and black and these sorts of things. If you have a message that is going to be important to scale by population, then you should do that. If your message is not, then you should not, and so on. So as a data visualization expert or participant, you get to make the decisions about what you will employ and what you will use or not use or leave out, and so on. So, and hopefully that then that responsibility to each person then encourages each of you to continue along this journey towards understanding this field and trying to understand these tools. Yes. So with that, I think that we'll wrap up. We'll thank you, Cédric, for taking some time to talk with us today. And then you also let the cat out of the bag a little bit. We have another fantastic guest for next month, Klaus Wilke, who will be talking about more data visualization aspects, particularly use of color in some of these considerations. So if you are registered and participating now, then you can certainly, we'll send links and also alert you to some of these other data visualization centric virtual meetups. So with that, thank you. very much for all of you attending. And Cedric, thanks again.
Bye-bye. Have a nice week.